All right, good morning, class. Let's see, we have Kelly Bradshaw here today to give y'all some information for those of y'all that are education majors. Kelly, you can take it away here.
Thank you so much for allowing me to come in, Mr. Stein. I appreciate it. Good morning, everyone. My name is Kelly Bradshaw, and I'm one of the math faculty here at MVC. And I also work on our community math grant, which is designed to help pre-service teachers get some additional experience and some more information as they're working through their associate's and bachelor's degree. Do I have any elementary education majors or education majors in here today? If you are, be sure to do me a favor and put your chat, open your chat box, because I'm going to put a few things in there for you. Louise, is it Luz or Louise? Victoria, are you a education major also? No, you're just turning on your camera. Good for you. So what I put in the chat right now for you is first off my email. So if you have any questions about what I'm talking about today, definitely shoot me an email. Make sure you write that down. The second is that we have a community of educators meeting tomorrow night at 6:30, and the Zoom link is there for you. This month, we have one every month, and this month we're talking about what your opportunities are here at MVC, as well as UTSA if you decide to transfer there because they are part of our grant. And we have a student teacher coming to talk for a few minutes about the realities of student teaching. So it's going to be a really good meeting. The last thing is a playlist on YouTube of all of our different opportunities that we have. So if you click that link, it'll take you to be able to just check out all the different opportunities that we have there. I'm also going to put a couple of flyers in here. Again, if you are an elementary education major, then after you finish this class, you could do our peer or parent tutoring programs. And those are going to be on the flyers as well as the videos. And if you are an elementary education major right now, before you even finish this class, you have some options like our math enrichment program that'll help you with this class. Spanish enrichment, that's going to help you with some math vocabulary in Spanish to talk to your ESL students or your parents that only speak Spanish. And our Investigate Your Learning course, where you really get to understand what it means when we learn something and how all that works. So please take a look at the links. And if you have any questions at all or would like to get signed up for some of those, send me an email after class and I'll be happy to sign you up. Thank you so much. I don't want to take any more of your time because I know that you guys are busy, and have a great day.
Thank you, Kelly. All right, class. So you're an education major. That's going to be some really helpful information there. All right, let's get started. So here is the exam from last time. All right, so first thing we're going to do is work the problems from the exam. So number one here, we want to solve for x, right? So looking at this, we're taking a number, adding 2 to it, and getting 5. At this point, you should be able to look at this and know x has to be 3, because only 3 plus 2 equals 5. Okay, but to show your work, right, what we want to do is we want to say, okay, x plus 2 equals 5 if and only if x plus 2 minus 2 equals 5 minus 2. You know, we want to subtract 2 from both sides of this equation. And if that equality is true, then this 2 minus 2 go away and we have x equals 5 minus 2 is 3. And we put a happy box around that. All right, so now for number 2. All right, so what are we doing here to our x? We're multiplying our x by 3 and we're dividing it by 4. So what we want to do here is, in order to get rid of this 3, we need to divide both sides by 3. But we're also dividing x by 4. So we need to multiply both sides by 4. And now you see the 3/3 cancel, 4/4 cancel. All of this here is just 1. 1 times x is just x. So 1 times x is just x. 4 times 1 is 4/3. So x is 4/3 here.
I had solved this a different way and I just want to make sure it was okay.
Sure.
I had written, sorry, I'm trying to understand I put it into my like good calculator
Okay.
without like, so I ended up just doing 1 divided by 3/4.
Yeah.
And
you
it
can
gave
do
me,
that.
okay,
Yeah, you can do that because you could say, I mean, 3/4 is just a number, right? Divide both sides by 3/4. Okay. So 3/4 over 3/4 is just 1. And 1/3 would be 4/3. When you're dividing by a fraction, that's the same as multiplying by its reciprocal. Okay. You can think of 3/4 as just 0.75, right? So you're just dividing both sides by 0.75. All right, any questions?
So if we got a decimal answer, did we get it wrong?
All right, if you have 0.75x equals 1, you just divide both sides by 0.75. And then you have x equals 1 divided by 0.75 would equal 1.25. If you plug it into your calculator, working with decimals. All right, if there's no more questions, let's start the day off with a quiz. Number 3. Solve for x. Number 1, we have 2/x equals 3/4. Number 2, let's do 2/3 equals 4/x. All right. So let's take 15 to work on this. It's 10:38, so 10:48, 10:52. We'll come back and work these problems. Let me put you in your breakout rooms. So breakout rooms. 2 rooms. Create. Open. All right, class. Before we look at quiz number 3 here, let's go back up to exam number 2. I made a mistake. Over here, I'd written some stuff. 3/4 is the same thing as 0.75. Right? I said, well, you can just divide both sides by 0.75. That's 1. So we just have an x here. And 1 divided by 0.75 is 1.3 with a line over 1.33333. So that's a correction from exam 2 here. So now for our quiz. All right. Remember when the variable is on the bottom, you can just flip both sides, just compare the reciprocals. So you put an x/2 equals 4/3. Just compare the reciprocal of both sides. So from here, since we're dividing x by 2, we need to multiply both sides by 2. So the 2 over 2 go away. Because 2 over 2 is just 1, and we have x equals 4 times 2 is 8, and then over 3. That's one way to do it. Or you could do the cross multiply. Do the flip or cross multiply. So 2 times 4 equals 3 times x. Okay. So from there, since we're multiplying the x by a 3, see 2 times 4 is 8, 3x. Divide both sides by 3. So we have x equals 8/3. Any questions about number 1? Number 2, we'll do the same trick here. Since the variable's on the bottom, we'll flip both sides. 3/2 equals x over 4. And now because we're dividing the x by 4, let's multiply both sides by 4. So the 4's go away. We have x equals 4 times 3 is 12 over 2. And 12 over 2 is 6. All right, any questions about them? All right. If you're having difficulty with these, it's just a matter of practice. The work is what teaches you.
Okay, so I like when you wrote out the second way, so you know how like the if and only if, that was confusing me at first, but then I started to realize it looks exactly like how when I'm writing out my work and like breaking down the problem, I always put like a normal arrow pointing to like the next step. So I just add the little lines on it and it's the same thing.
There you go. Yeah, it's the flow of logic. See, we do it both ways because you could start here and you could say, well, if x equals 6, then 4 times, let's see, then 12, this is still 6. This is still x equals 6. So, but if x equals 6, then 3/2 is equal to x over 4. So if you multiply both sides by 4, you get x equals 6. Yeah, so
And,
flow of logic goes both ways.
and you only multiply that one number to the numerator, never the denominator, right?
We're at up here.
Just like in those equations, yeah.
Well, if you multiply both sides, you have to multiply both sides. And when you're multiplying fractions, you'll only multiply the top of the fraction. Yeah.
The top, yeah.
Yeah,
Because if
like-
you multiply the denominator, it's gonna throw the whole thing off.
Yeah, if you're multiplying 4 times 3/2, you only multiply the 4 times the 3.
Okay, yeah, that was kind of getting to me at first.
Because look, if you had, right, you have 4, when you multiply, right, that means 4 of these, that means 3/2 plus 3/2 plus 3/2 plus 3/2. Remember, that's what multiplication means.
Yeah,
Repetitive addition, we're taking 4, we have 4 of these, so we're just adding them together 4 times. If I did 4 over 4, meaning multiply the top and the bottom, right? Well, 4 divided by 4, this is just the number 1. So if you multiply the top and the bottom by that number, you don't change anything. You see what I mean?
yeah,
Make sense?
sure, that makes sense.
Okay. All right, so that's our quiz. due by midnight tonight. And now we are on page 11 in our little book here. So now we're getting into percents. All right, it's going to get a little hectic here, but not too bad. All right, a fraction or a ratio is a number of the form A over B, where A is called the numerator and B is called the denominator. There's basically a number on top and a number on the bottom. A fraction may also be thought of as a part out of a whole. So the shaded region represents the fraction 1/2. It may also be written as a decimal 0.5 or as a percent 50%. So the part out of the whole, 1 out of 2. 1 over 2 is 0.5 as a decimal, which is also known as 50%. Again, the percent means per century or per 100. So 50% means 50 per 100, and 50 over 100 is 1/2. Okay. If you take the 1/2, all right, this is 0.5 or 50 out of 100, which would be 50%, 50 per 100. All right, a ratio may only be expressed as a percent when the units of the numerator and the denominator are the same. So this fraction here, we have dollars versus slices of pizza. That cannot be written as a percent, okay? Slices of pizza compared to slices of pizza, yeah. Slices of pizza cancel out of the fraction. This is just the number 1/2, a pure number without units, okay? So if you're going to write something as a fraction, as a percent, the fraction has to have the same units on the top and on the bottom. Because if they do, then the units cancel out. Slices of pizza over slices of pizza, those cancel out of the fraction. Okay. So this example, we have 1, 2, 3, 4 total, but 3 out of 4 are shaded. Okay. 3 out of 4 is 0.75. 0.75 is 75 out of 100, which is 75%. That's how that works. Go into the decimal. All you do is you move the decimal over twice, and that's your percentage. All right, let's look at proportions here. All right, a proportion is an equation of the form ratio equals ratio. That means it looks like this: A over B equals C over D. Okay. So for an example, suppose after you graduate from college, you start a job earning $21,500 over 6 months. If your pay stays at this rate, how much do you earn in a year? All right. Well, you might think of this, well, if I make this much in 6 months, how much do I make a year? Twice that, right? That should be fairly obvious because a year is 6 months twice. Or we can solve this using a proportion. All right. So what they're saying is $21,500 is equivalent to 6 months, basically. So you put that in a ratio. 21,500 per 6 months equals how much compared to 12 months? So you're comparing, here's your wage for 6 months. What's your wage for 12 months? The ratio should be the same. So that's the setup here. We have months on the bottom. And on the top is how much we make in that many months. So if you set up this equation, now you have to do is solve for X. So since our X here is being divided by 12 months, we're gonna multiply both sides by 12 months. You just go boom, times 12 months, times 12 months. See, when you multiply both sides like that, 12 months go away and now we have X by itself. Now on this side, the months cancel out and we have 12 over 6, which is 2, times this many dollars. Okay. So in the end, you can see all you're doing is multiplying 21,500 times 2, which is what you should have thought when you first read it. If I make this much in 6 months, how much do I make in a year? Well, twice that. And this proportion shows that. That's how you set that up. So we'll use proportions. They're a lot easier than you'd think. You'll get used to them because we're going to be using them all semester.
Question.
Yes.
So theoretically, we don't have to break it down into 21, whatever, blah, 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 times 2. We could just do 21,500 divided by 6 times 12 in a calculator, because I got the same number.
Yeah, you could do that. You could say, well,
Okay.
if I make this much in 6 months, I could divide it by
Gotcha.
6 and find out how much I make in 1 month. And then multiply that by 12, because that's how much I make in 12 months, right?
Yeah.
Yeah, that's
Okay,
one way
cool.
to get it.
Could
Awesome.
you multiply 12 times 21,500 divided by 6?
Yes, that's what we're doing here. The 12 over 6. 12 over 6 is 2, right?
So let's say you didn't want to simplify that.
Huh?
Let's say you didn't simplify that, like, and you got like the biggest number by doing 12 times 21,500. You could still get the same answer, right?
It's the same answer. Yeah, if I take this and then multiply that by 12 and then divide by 6, that's the same thing as, since this is 2, it's the same thing as just multiplying it by 2.
Okay.
All right. So let's look. So if you make $9,800 in 3 months, how much will you earn in 1 year? Well, one person said, well, if I make this much in 3 months, I just divide this amount by 3. That's how much I make a month. So in a year, I'd have to multiply that amount by 12. That's one way to do it. Or since they want us here to use proportions. So let's do the proportions to solve this. They're saying 9,800 per 3 months is the same as how much in 12 months. I need to put my months here, months. So $9,800 is equivalent to 3 months. So how much would be equivalent to 12 months? Okay, so since our X here is being divided by that, what we're going to do, since it's being divided by 12 months, let's multiply both sides by 12 months. Now that and that cancel. I have X by itself here. Now over here, the months go away and I have 9,800. 12 over 3 is 4. So X is, let's see, 9,800 times 4. 9,800 times 4 is 39,200. So that's how you do this with proportions, okay? Just comparing, they're basically saying $9,800 is equivalent to 3 months. So how much is equivalent to 12 months? They should be equal, okay? All right, page 13. Answer the following in your own words. Would you rather use a coupon worth $20 off your entire purchase or 20% of your entire purchase? So what do y'all think, guys and gals?
Depend on the amount you were, like how much the thing you were buying was.
That's right. Let's see, look, if you spent $100 and you got $20 off, right? Let's see, what 20% of $100 would be $20, right? All right, 20% of $100 would be $20. So $100 here is your cutoff point, right? If you're spending more than $100, you want 20%. If you're spending less than $100, you want $20 off. Does that make sense? All right. If you're spending $1,000, you want 20% off because that would be $200 off. $200 is way more than 20. All right. Depends on if you're spending more than $100. All right, let's look at number 2. Suppose someone leaves a $20 tip on a $200 check. Is this a good tip or a bad tip? Well, 20 compared to 200, the dollar signs go away. 20 over 200 would be 0.1, which is 10 over 100 or 10%. So is 10% a good tip? Depends on the service, right? All right, so what would be a better tip? 15%, right? Would be decent, right? 15%. Well, what is 15% of $200? How do we find that out? All right, well, 15% is the same as 0.15, right? So to find that out, you take your $200 and you multiply it by 0.15. Fix this. That's how you find your percentage. 200 times 0.15. It's $30. $30 would be 15%. Okay. All right. Or you can write it like this. 215 out of 100. Okay. This is your 15%. Which is, dang it, $30. So to find your percentage, you just multiply your number times your percent there. And that's how you get your percent. So let's look at a whole bunch of these. All right, what is 35% of 200? You take 200, you multiply it by a 0.35. 200 times 0.29, which is 70. Okay. So looking at this, this is the same thing as saying 200 compared to, let's see, how can I do this? Using proportions. I don't know, I like it this way better. So this is your percent, right? This is what you started off with, and then you get your result. So this one is worded a little differently here. 35 is what percent of 200? Okay. Well, they're saying if you start off with 200 and you multiply it by your percent, you get 35. Okay. So we need to find our percentage here. All right, it's a lot like this one, right? This one, what is 35% of 200? That was our setup last time, and we found that this was 70, x is 70. Down here, the variable is different. This was asking about what 35% of 200 is. Here we're asking what percent. Okay, so to get to x here, we need to divide both sides by 200. That goes away. So 35 out of 200 is 0.175, or 17.5 out of 100, or 17.5%.
If we were given this question on like a test, you would want the answer to be in a percentage, correct?
Yeah, because that's
Okay.
what we're asking for, what percent. Okay, so number 5 here, 25 is 40% of what? So just like our setup here, we have a number, we're taking 40% of it, and we're ending up with 25. So 25 is 40% of what? So here's our what. We take 40% of it, and that gives us 25. So that's our setup. So now how do we get to the x? Well, we need to divide both sides by a 0.4. So 25 divided by 0.4 equals 62.5. Okay. So we can check our work. Check. 25 is 40% of what? We're saying 62.5. If I take 62.5 and take 40%, I get 25. That's what they're asking. 25 is 40% of what? Well, it's 40% of 62.5. Number 6, 15% of some number is 19.5. So we have some number, we're taking 15% of it, and we're getting 19.5. Calculate that number. Well, to get x by itself, we need to divide both sides by 0.15. So 19.5 divided by 0.15 is 130. So our little formula here, there's 3 numbers. There's a B, and a C, right? Something times something equals something. So every one of these problems is a little bit different. This one, they're asking about the middle number, the percent. This one, they're asking about the result, all right? And then this one, they're asking about the original number you start off with. So these 3 are asking about 3 different quantities, all right? So there's only 3 different kinds of problems you have in percent land. So number 7 here, 35 is 15% of what? 35 is 15% of what? So we got some what. We're taking 15% of it and we're getting 35. Okay. So 35 is 15% of what? So now we need to get our X, so we'll divide both sides by 0.15. 35 divided by 0.15. 233.3 with a bar over it. Okay. All right, page 14. Doing proportions again. 30% of all students at Northwest Vista transfer to UTSA. Of these transfer students, 12% are going to major in biology. If there are 15,435 students at Northwest Vista, how many will transfer to UTSA and major in biology? Well, let's see. We start off with 15,435 students, right? 30% of all of them are going to UTSA. And then 12% of those, of the ones that transferred, are going to major in biology. And we want to know how many are going to UTSA and majoring in biology. So transfers is 30%. Okay. So 15,435 times 0.3. This is 4,630 and a half. That's how many are transferring. So bio majors, of those transfer students, 12% are going to major in biology. So we need to multiply this by 0.12 to get 12% of that. So times 0.12, which is 555.66 students are going to be transfers and bio. Notice what we're doing here. We're starting off with the original amount. We're taking 30% of that, and now we're taking 12% of that. Okay. So 30% are transferring, and then 12% of those are bio majors. So take 30% of 15,435, and then now take 12% of that. You can do it in one step or two. Number 9 here. 30% of all students at Northwest Vista transfer to UTSA. Of these students, 12% are majoring in biology. What percent of NVC students are going to be at UTSA to major in biology? Isn't that the same question?
It's like the same question, but numbers are missing.
Let me move it up here. Let's compare these. They look the same to me.
It's the same question, but they're missing the amount of students to solve it, it looks like.
Oh. Yeah. Okay. That makes sense. So they don't even tell us.
Like unsolvable.
Well, not necessarily. Let's see. They're asking what percent are going to be at UTSA to major in biology, right? So no matter how many students we have, let's say there's X total students at Northwest Vista. Or here, I'll use NVC. This is how many students at Northwest Vista, right? They're saying 30% transfer to UTSA and 12% major in biology, right? So what percent are going to be at UTSA and major in biology? So this is the UTSA and UTSA bios, right? So we start off with all Northwest Vista, take 30% and then 12%, and that gives us how many of them that are at UTSA and bio majors, okay? So they're asking just what percent though. It doesn't matter what this number is, okay? What they're looking at is this. That's the percentage. Let's see. I guess to show you that, what percent? So what we want to know is the percent. So the percent would be the ratio here, right? The total Northwest Vista students compared to UTSA transfer bios, right? This is our percent that we're looking for. Okay. So let's see.
How likely are we going to get a question like this on a test?
Well, this one isn't as complicated as you'd think, okay? Because the number is right here. I'm just trying to show why that's true.
So that middle section, that would be the answer to the question. Would
Yeah,
0.3 times 0.12, that would be the answer technically.
yes.
Okay.
It would be 36%.
No, let's see. 0.3 times 0.12 is yeah, 0.036, which would be 3.6 out of 100, or 3.6% is your answer, right? Because we're taking 12% of 30%. So 12% of 30% would be 3.6%. I'm just trying to show it here. Because if we have this, if I divide both sides by UTSA bio, this is just the number one, then I'd have to divide both sides by this. It's just not, I don't know, my brain's not working very good today. But anyhow, yeah, this is your percentage right here. You're just multiplying these two percentages together. Let's see, how can I show this with proportions? Is the ratio of Northwest Vista students to the UTSA transfer bios is the percent we're looking for. Okay. Oh, I don't know. I'll just leave it as this. We'll come back to problems like this later. Well, I guess one way you can do it is use the information from the last problem, right? See, this was the number that is both UTSA and bio majors right here. Well, if we compare this to the total number, right, we are going to get 555.66 divided by 15,435 is 0.036 or 3.6%. You see what I mean? So using the numbers from the last problem, we get our percentage, right? And that's what I was doing wrong. I got it upside down. That's what I was doing wrong. The percentage is the UTSA bio compared to the total NVC. That's why I was going wrong here. So yeah, if we take our NVC, multiply it, take 30% and then take 12%, that gives us our total UTSA bio students. The percent we're looking for is the ratio of UTSA bio students to the total NVC students, right? That's what we want. So looking at that, if we look at this, right? We have NVC, take 30%, take 12% of that. Well, if we divide both sides by NVC here, you can see that this is the same as this. That's our percentage right there. It's 0.3 times 0.12. Sorry, I had my fraction upside down earlier.
No, that's why I hate problems like this. I always mess up like which should be up and which should be down and like the placements of the equations.
Yeah, that's the hard part. Once you get it set up, then it's just a matter of calculating, right? But the setup is key. You have to really think it through here, you know, and look at it from a lot of different angles. Make sure that you have the setup correct before you start doing your calculating usually. So this problem doesn't say anything about how many students there are at Northwest Vista. And we don't need to know how many there are because all they want to know is the percent. Now I went back to the other problem where there's actual numbers for how many students, and I used that to find out what the answer was. All right. And I use that information to help me do the setup here for this problem where they don't tell you how many Northwest Vista students, because you should get the same answer. This is 3.6%. All right, I should get the same answer either way. Okay, but again, this problem, it doesn't matter how many Northwest Vista students there are. You're taking 30% and then 12%. Well, that's 3.6%, no matter how many there are. All right, number 10. All right, in a Gallup poll of 976 adults, 68 said they drink alcohol every day. What is the percentage of respondents who said they have a drink every day? Part out of the whole. 68 out of 976 is 0.0697. It's an approximation. So this would be 6.97 out of 100 or 6.97%. So notice I had to move the decimal over twice, right? More on proportions. Here we go. Set up a proportion and solve. Joe's heart beats 11 times in 10 seconds. At that rate, how many times does his heart beat in 60 seconds? Well, they're saying 11 times per 10 seconds. So they want to know, well, how many times does it beat in 60 seconds? So there's our setup. Now to solve it, we need to get our X by itself. So let's multiply both sides by 60 seconds. So that goes away, and now I have X by itself. Now over here, look, seconds go away. We have 60 times 11 over 10 times. So 60 over 10 is just 6 times 11 would be 66 times. All right, let's see. Any questions? One plain bagel has 320 calories. How many calories are in 2.5 bagels? Well, one bagel is 320 calories. So how many calories are in 2.5 bagels? So we got bagels on top, calories on the bottom. All right, so that's our setup. So let's flip both sides, right? Because our variable is on the bottom. So let's just flip over both sides. Okay. Now, to get x by itself, let's multiply both sides by 2.5 bagels. So that goes away and we have our x by itself. So we have x equals, these bagels go away. We have 2.5 times 320 calories. And 2.5 times 320 is 800 calories. All right, how y'all doing, folks? Y'all need a short break? We have about an hour left.
No, I'm good. I finally got the dogs inside. Stop barking at the neighbors, so I can actually pay attention fully now.
All right, well, we'll skip our break then, and we'll just let out a little early then. All right, a leaking pipe can lose 24.7 gallons of water in a week. How many gallons are lost in 30 days? Well, it says 24.7 gallons is the same thing as 1 week. So we compare that to how many gallons versus 30 days. 30 days. All right, well, we have an issue here. We have weeks and days. We need to have the same units. All
Can
right.
you just change 1 week to 7 days?
Yeah, exactly. Let's change that to 7 days. Now we're comparing days and days. Okay. So now to get our x by itself, we'll multiply both sides by 30 days. So that goes away. We now have our x by itself. Now looking at all this stuff over here, the days cancel out. We have 30 over 7 times 24.7 gallons. So we use our calculators and multiply that all out. 30 times 24.7 divided by 7 is 105.86 gallons. All right, questions?
I thought that this would have been solved the same way as the flipping.
Well, the variable's not on the bottom of the fraction, so we don't need to flip both sides. See what I mean?
Ah, gotcha.
Mhm. All right, applications of percent. That's what we can do here. Use the following to solve. So here they give us a formula. Price plus price times tax rate equals total. All right, so that makes sense. To find out your total, you have to take your price add your taxes and you get your total. So this is your taxes. All right, you multiply the price times the tax rate. And then you add that to the original price. Now looking for a percent decrease or a percent increase, you look at the ratio of the difference between the new and the old over the old. So let's check out an example here. Amy bought a pool hall for 219,000. Hold on a second. Hey, get out of there. No, go play. Go on. Quit chewing up diapers. No, go. Sorry about that. All right, Amy bought a pool hall for $219,000. This price includes a 5% state tax. What was the price of the pool hall before tax? All right, so we're going to use P for price. All right. The price before tax, that's what we want to find out. But this is the amount after tax, right? So we had this price and then we added to it the taxes and we got 219,765, right? All right, well, the taxes, what are the taxes? The taxes is going to be your price times your interest rate. So let's replace our taxes here. 5% is 0.05. All right, you got to move the decimal twice, right? Boom, boom. So 0.05. So the price plus the taxes was 219,765. So this is our equation. And you can see it's the same as up here. Price plus price times tax rate equals total. Okay, so this is our total, price times tax rate, and our price. So how do we solve for P? What we have to do here is factor, all right? Remember, A, let's see, if I have A plus 2A, all right? Since both of these have an A, I can factor the A out. This would be a 1 plus 2, right? A plus 2A is obviously 3A, right?
Wait, it says this price includes the 5% tax rate. So isn't the 219,000 the total rather than the price?
It is the total, yeah.
Oh, okay.
This is the total, right? So you're taking your price, adding your taxes, and then you're getting that much.
Oh, okay, I was confused. I guess I just didn't see the problem right. I thought you were using the 219,000 as the price for some reason. I don't know.
Yeah, there's a lot of weird words going around here, but yeah, we're taking the original price, adding the taxes and getting the total. What we need to do here is P shows up twice. We need to factor out the P. So this is our next step. You can do it like that, or you could say, this is 1P, this is 0.05 P's, just add them together, right? So since we haven't gotten to factoring yet, let's just do it like that. If we add these together, just like this, if I have A and 2A, I add them together, I get 3A. Well, if I have A and 0.05A, I add them together, I got 1.05A. Because A here, this is the same thing as 1 times A. We just don't write the 1, right? So we have 1P and 0.05P, so this is 1.05P. Does that make sense? All right. If I just got rid of the
Wait,
P,
no, I'm confused. Yeah, because wouldn't it be, if you added P plus P, wouldn't it be 2P?
it would be. All right, but this is 0.05 P. Right?
Mhm.
So just like A plus 2A would be 3A, right? Well, A plus 0.05A is 1.05A. You have a whole P here and then 0.05 P. So if you add those, you get 1 and 0.05 P. You could think of it like this. P, because there's really a 1 here. We just don't write it. P is the same as 1P, right? Well, you have a P times a 1 and a P times a 0.05. So this is 1.05 P's.
Yeah, but I thought one was kind of just a stand-in, like it's 1P as in one of the variables. It doesn't actually mean one, right?
Well, whatever this price is, right? The 1 times that price is the same thing, right? If you multiply anything by 1, it doesn't change anything, right?
It's because they factor each other. So when we're bringing in, because I used to think of it the same way with the 2P, it used to confuse me, but when you write it up, when you set it up as a factor method, it looks better. It's kind of throwing Victoria off because it looks like we have 2Ps, but we don't. When we
Right.
factor it out, it
What would it look like as a factored formula?
it's
Because that might look a little easier.
That's
Yeah.
up here, right? I have a P times a 1, and then I have a P times a 0.05. So what I have is this P times a 1 and a 0.05, right? Because you would distribute this. All right. Yeah, P is the same thing as 1 times P, right? So I have 1 whole P and then I have 0.05 P. If I add them together, I get 1.05 P.
Wouldn't it be easier to look at then instead of 1P plus P 0.05? Would it be easier for it to be 1P plus 0.05P?
Yeah, if you want to write it like that, because it's the
I
same.
feel like that would look a lot
That makes a
easier.
lot more sense to me. Like
Yeah, because
I
it looks like P is its own thing.
0.05 P. Yeah, they're the same thing because A times B is B times A. So however you want to rearrange it, is fine. I wrote it like this because that's how they have it up here. Price times tax rate. Okay. So, but it's exactly the same as this. If you have A and 2A, you add them, you got 3 A's. Well, I have 1A and then I have 0.05A. If I add those together, I get 1.05A. That's all we're doing right here. We're just adding. So now at this point, to get the P by itself, you divide both sides by 1.05. And we 219,765 divided by 1.05, which is $209,300. So we can check our work. Let's check. If I have 209, dang it. I have $209,300 and I take 5%, right? So times 0.05. 5% would be $10,465, right? So the total would be the price plus the taxes, right? So plus 209 gives us 219,765. All right, nearly every problem we do in here, there's a way to check your work. So always check your work, okay? A lot of students will do really simple problems, make a mistake, and not check their work, and then they lose half their credit on their test, You always want to check your work. So at number 15 here. Steve needs to buy his sister a birthday gift from the mall. He sees a shirt that is normally priced at $24.50, but it's on sale for 20% off. If the sales tax is 8.2%, how much will he pay for the shirt? All right, well, you start off with your $24.50, right? Let's find out how much is the discount. Discount is 20%. So we multiply the total by 20%. We have 24.5 times 0.2 is $4.90. That's the discount. So price with discount is $24.50 minus that 20%, right? $24.50 minus 4.9 is $19.60. So now we have to add tax. So the tax is 8.25%. So we take our 1960 and multiply it by 0.0825. And that gives us $1.62, rounding up to the nearest cent. So the total is 1960 plus the tax, right? 1960 plus $1.62, which is $21.22. Okay, it's your tax. This is the price with the discount. Another way to do this, instead of going 0.2 here, saying what is the discount, I could have said could have skipped all that. I could have said price with the discount is $24.50 times 0.8, because if it's 20% off, I'm paying 80%, right? So $24.50 times 0.8. That's not right. Which is $19.60. So up here I did 20%, subtracted that from the previous price to get the new price. Or instead of taking 20% off and subtracting it, I could have just said, oh, we're going to do 80% is what I pay instead of this how much I get off. And then the tax follows the same way. Okay. Look at number 16. All right, Thomas is selling his Honda CR-V on consignment by leaving it with a dealer who will get 25% of the selling price. What must the selling price be in order for Thomas's share to be 1,475? All right, let's think about this. Thomas is selling his Honda. He's giving it to a dealer to sell. The dealer gets 25% of the price. What must the selling price be in order for Thomas's share to be 1,475? So there's a price, P. All right. Let's see. There's a price. The dealer gets 25%. All right, if the dealer gets 25%, right? Thomas gets 75%, right? So if we have a price here, and we take 75% of it, Thomas wants his share to be $1,475. All right, does that make sense?
So we would just basically find 25%. Oh, never mind. I got confused. Sorry.
That's good. It's all right. Yeah, the dealer wants 25%, so that means Thomas gets 75%. So if we take 75% of the price, it needs to be $1,475 because that's how much Thomas wants. All right, so that's our setup. So to get P by itself, divide both sides by 0.75. So let's see here. 1,475 divided by 0.75 equals $1,966.67. Let's check our work. So if we take this, all right, and we take 75% of it, we get $1,475. Boom. All right, in 2004, Javier bought a new television set for 2,500 bucks. In 2012, he purchased a similar model for 950. What was the percent decrease from 2004 to 2012? Round to the nearest 1/10 of a percent. Well, they gave us a formula right here. So I'm not doing that one. Looking at this, new minus old. Let's see. This is the new price. Here is the old price. They say do new minus old over the old. Multiply that by 100. And you get the percent increase or percent decrease. So
Wouldn't the 2,500 be the new price? Because 950 was in 2012.
well, 2,500 was in.
Oh my God, I'm stupid.
Right? So, yeah, 2,500 would be the old price because it's from 2004. Yeah. So we get, let's see, 950 minus 2,500 is a negative 1,550. The dollars go away. So 1,550 divided by 2,500 equals, this would be negative 62%. Once we multiply it by the 100. So you can see the negative here, that means decrease, okay? So it's just the difference in the prices divided by the original price gives you the percent, okay? So if you think about it, you know, the difference between this and then divide by the original one. Okay, so you really shouldn't have to memorize this formula. The formula should kind of make sense conceptually, you know. So that's number 17. I think we're going to do 18 here, and then we'll do our exam. Get out of here. All right, the price of gas increased from $3.25 per gallon to $4.05 per gallon. What was the percent change to the nearest percent? Well, we look at the difference. So it went from 325, it went up in price, right? It went up in price. So our percentage here, our percent change is going to be a positive one. So we do 405 minus 325 over the old price. Right? The difference in prices over the old price. And then we multiply it by 100. So we have 4.05 minus 3.25, which is 0.8. Now divide by 3.25 and multiply by 100. And we get 24.62%. All right, any questions? All right, let's do exam number 3. There we go. Solve the following equations. Oh. This will be your number 1. This will be your number 2. So notice I'm pulling these out of the textbook itself. That means the answers are in the back of the book, I think. So if all you do is write down the answer, you're not going to get any credit. You need to show your work. Show me that you know how to solve these. So there's your exam. It's due by midnight tonight. And then I will see y'all. What's today? Wednesday? What's today? Yeah, I guess I will see y'all on Monday then.
Alrighty, I've got a question on that. I know the school said that by the 29th is when they were going to be stopping the Zoom and see about doing it in person. So I'm assuming when we return on Monday, we're going to be doing Zoom, or is it going to be in person?
That's a good question. Let me check my email real quick. I forget what the dates were.
Yeah, I think it was like the first 2 weeks of school. Was it ending out on the 29th? I could be wrong.
Mr. Stein, they sent out an email yesterday saying that as of yesterday, they were planning on going back to in person. I don't know if anything's changed.
Yeah, I forget what day it is though. So the first 2 weeks, this has been 2 weeks, right? So
Yes,
Right.
sir.
yeah, we should be on campus.
You were giving us the option to still attend via Zoom.
Yeah, when I'm gonna go to class, I'm gonna use the same setup here in class. I'll have this tablet hooked up to the overhead projector so y'all can see what I'm writing. So you can still just zoom in if you can't make it to class. Yeah,
Okay.
Cool.
All right. Awesome.
yeah.
All right.
We'll plan on going back to class on Monday then.
All right. Thank you.
All right.
Would the flipping mechanism be used in this exam?
Yeah, on both of these, you're gonna want to flip both sides because your variable is on the bottom.
So it's kind of like the stuff we did like at the beginning of class, right?
Yeah, exactly the same.
Okay, because those word problems are pretty difficult.
They'll get easier. You have 4 months to master them, so.
Yeah.
I agree. I kept on messing up like on where to put them or how to solve the equation. Like I'm fine with like the actual equation solving, but when it comes to word problems, I mess up so badly with how to configure the problem.
The word problems are,
What
hard.
helps for me is underlining,
Yeah,
underlining all the
For
numbers.
the one with
and
like the 25 and 75%, like it didn't even cross my mind that like, oh yeah, I have to like, it's 75%. I have to, subtract because the person wanted the 75%. Like, I don't know, maybe I'm just tired. Like hopefully like once I have a break and I can review them and I'll do better. But like at the same time, it's just like,
Right,
oh.
get the same thing.
just practice a little every day. It'll make more and more sense and get a lot easier, but you have to practice a little every day.
And there's also tutoring.
Yeah, hit up the tutoring if you can.
Like a plan.
Mr. Stein,
Yes,
yes, sir. Can you show the quiz again so I can write it down?
yeah. There you go. And you can always get the quiz and the exam out of the lecture notes because I upload them into Canvas after class every day.
This
Got
is the one that's due tonight, right?
Yes.
Yes, sir.
I got a
Okay.
question on that because I clicked on the hyperlink that you have in the syllabus for the YouTube for the lectures,
Yeah.
and I keep run and I can find where you have uploaded, what is it, lecture 1, lecture 2, and so forth. But then when I click on those different lectures that I see, I guess in the catalog area, I'm seeing stuff that I'm like, what in the world is this? I haven't got a clue. So do they scroll in at the bottom or is it at the top?
I don't know. I haven't looked at it. I just know I got them on YouTube. There is a playlist there.
Okay.
So try to find the playlist with the title of your class so that you can just find the lecture there because you're probably clicking on lectures to my other classes.
Yeah.
We'll just put a list of anything I've uploaded, but if you find that one that I linked to, it's in a playlist
Okay.
with a class.
I guess maybe I'm just too old and this electronic fingle stuff is a little bit beyond me, but that's okay. We're adapting.
You'll get it.
All right. Thank you.
Sure. So yeah, if you get something like this, you'd round it to where you have 3 numbers after the decimal.
Right.
If you got something like this, your calculator just says 3.5,
Right.
then that's your answer.
Okay. Okay. All right. Thank you.
So on the first one, like I'm getting an answer, but I'm like fact checking it and it's wrong and I can't really see what I'm doing wrong in the process.
Are you flipping both sides of the equation first?
Yeah, I'm flipping it both sides. So you have t over 30 and 3.4 over 5. You multiply the 3.4 over 5 by 30 and I keep on getting 20.4, but I'm putting that in and it's not.
5 times 30, 20.4. Yeah, that looks right.
Yeah, but then if you, like, I'm putting that in the box, like 30 divided by 20.4 is 0.9868 such, and then 3.4 divided by 5 is,
Right. This number is 1.47 and it goes on and on and on. So if you take 30 and divide it by what, 20.4? You get the same number.
Yeah, I just took the the 30 over t and then I did whatchamacallit.
No, I mean, like when
Did-
I'm plugging 20.4 into the equation, like they don't equal the same, like,
Well, if you take 30 and divide it by 20.4, you get 1 point something, something, something. And if you look at the other side of the equation, if you take 5 and divide by 3.4, you get that same 1 point something, something, something.
you're right. I don't know. I think I was plugging in different ones for the flip side. I don't know. Now it's working.
All right, rock and roll.
I guess that was just I didn't structure it right. So when I was plugging it in, I was plugging it in wrong. Okay, well, that helped. Thanks.
Sure.
So me just flipping both sides and then carrying over that 30 times 3.4, I got 102 over 5 and I divided that and got t equals 20.4.
There you go.
All right, cool. I'm not as dumb as I thought it was. So
Thank you for the help. We'll hopefully see you next week.
All right.
yeah. All right, cool. And I guess the same thing for number 2, right? Just
Yeah, exactly. Same process.
and then flip 10 over 3. See, that's what was messing up me before, like beginning of the class. I didn't know that you had to flip both sides. I had to remember how to do that again.
Yeah, you can't just flip one side because you want to maintain equality. Whatever you do to one side, you have to do to the other side.
I did 10 times 14 and 140 over 35, x equals 4. That would be number 2. Okay. I think I got it.
Okay, Professor. I think I got to hang it in, so I'm gonna sit and work on these so I can get them turned in. Thank you for everything.
Sure, of course.
Okay, right.
Bye.
Before I go, you'll send something out if you hear anything different about us being in class or not.
Yeah, if they tell me anything otherwise, I'll send you an email.
Yes, sir. The only thing I saw, I did see that email they sent out yesterday. It says as of yesterday, they were planning on being back in class.
All right, cool.
Thank you, sir.
Sure. Y'all take care.
And I'll go ahead and just submit the exam through Canvas and I think I got them.
Joseph, I apologize for disturbing you. That email about returning back to class, Because I'm actually looking at my emails right now. And I guess I didn't make the list.
I Googled it just now and they said Monday, we're going back to campus.
Okay, all right.
Oh, we are going back to campus?
Yeah, on Monday.
And what building were you in again? I'm sure it says, but
We are in Juniper Hall. Class number 337.
337. Is that on the first floor? How many floors are to that building?
I think there's 3 floors.
337 Juniper Hall.
All right. Thank you, Joseph. You guys have a good weekend, and we'll see you guys Monday. Thank you, sir.
Sure
All
thing.
right. I'll see y'all in person on Monday.
All right, cool.
Sure.